Here's a sentence that sounds completely made up. Wolves changed the actual path of a river, not the ecosystem, not the wildlife population, the literal physical route the water took through the landscape. Sounds like a stretch, right? Let's actually get into what happened. Start in Yellowstone National Park. In the 1920s, wolves were hunted to local extinction, deliberately, systematically, completely gone from the park. For 70 years, Yellowstone had no wolves at all. And without a predator, the elk population did what you'd expect. It exploded. Elk are browsers. They eat young trees, shrubs, and willow saplings, especially the ones growing along riverbanks. With no wolves around to keep them moving, elk started camping out in the most comfortable spots. Riverbanks, valley bottoms, the easiest, most delicious real estate in the park. And they stayed there for decades. The young willow and aspen trees never really got the chance to grow. Elk ate the saplings faster than the land could replace them. So what happens to a riverbank when the plants holding it together disappear? It erodes. Roots are what hold soil in place during floods and heavy rain. Without deep root systems along the banks, rivers start to widen, straighten, and lose their natural complexity. By the 1990s, parts of Yellowstone's river systems looked noticeably different than historical records from decades earlier. Then, in 1995, something happened that hadn't happened in 70 years. Wolves were reintroduced. 14 wolves brought in from Canada, released into Yellowstone. Researchers including William Ripple and Robert Beschta began tracking what happened next, and the results, published over the following years, were remarkable. Elk behavior changed almost immediately. Not just their numbers, their behavior. With wolves back in the landscape, elk could no longer safely linger in open riverbanks for hours at a time. Predation risk changed where they were willing to stand still. Ecologists call this behavioral effect the ecology of fear. The elk didn't need to be eaten to be affected. They just needed to be afraid. This idea itself was fairly radical when it was proposed. For decades, ecologists mostly measured predator impact by counting how many prey animals got killed. The ecology of fear argued something different, that the mere presence of a predator and the constant vigilance it demands could reshape an entire landscape without a single additional kill. Elk in open, exposed riverbanks are easy to spot and hard to escape from if a wolf pack appears. Elk in dense forest cover have options. So elk started favoring cover over convenience, spending less time standing exposed beside the water. And that fear alone was enough to change how the land looked. With elk moving more and grazing less in vulnerable riverside areas, willow and aspen saplings finally got the chance to grow undisturbed. Root systems returned, riverbanks stabilized. Some studies found rivers narrowing, developing more pools, and holding their banks more effectively during high water. Beavers came back too, since willow is their primary building material. Beaver dams create ponds, which create wetland habitat, which supports entirely different species than a straight, eroded channel ever could. A single beaver dam can transform a fast, narrow stream into a slow, wide wetland complex within a few seasons. That wetland cools the water, traps sediment, raises the local water table, and creates habitat for amphibians, waterfowl, and fish species that a straight, fast-moving channel simply can't support. So the presence of beavers isn't a side note in this story. It's practically a second cascade stacked on top of the first one, triggered by the same initial shift in elk behavior. One predator, reintroduced, appeared to ripple outward through elk behavior, plant growth, riverbank stability, and beaver populations. This phenomenon has a name. Ecologists call it a trophic cascade, when a change at the top of a food chain triggers effects that cascade all the way down to the physical landscape itself. It's one of the most famous examples in modern ecology. A short documentary version of this story, narrated by writer George Monbiot, went viral online, watched by tens of millions of people. But here's where I have to be honest with you, because the real science is messier than the viral video suggests. Some ecologists have pushed back on how cleanly this story gets told. Elk populations were also affected by drought, by human hunting outside the park, and by other predators like bears returning to the region around the same time. Researchers like Arthur Middleton have pointed out that attributing the entire river transformation to wolves alone oversimplifies a much more complicated ecological picture. Middleton's field research tracked elk migration patterns directly and found that many elk herds had already been shifting their movement long before wolves returned, partly due to a series of dry years that reduced forage availability near rivers, regardless of predator presence. Hunting pressure outside the park boundaries also thinned elk numbers substantially. During the same period, wolves were reestablishing themselves inside it, making it genuinely difficult to isolate exactly how much of the change came from fear of wolves specifically. The willows didn't recover everywhere wolves returned. In many areas, elk simply shifted their grazing patterns without disappearing, and recovery has been patchy, uneven, and slower than the popular narrative implies. So which version is true? Probably both, just less dramatic than the highlight reel. Wolves clearly played a real role in changing elk behavior. The elk behavior clearly affected vegetation in at least some areas. But calling it a single, clean cause and effect chain, wolves fixed the river, flattens a genuinely complicated ecological story into something simpler than reality, which might be the most important lesson buried in all of this. Nature rarely moves in one straight line of cause and effect. It moves in overlapping webs, wolves affecting elk, elk affecting willows, willows affecting riverbanks, riverbanks affecting beavers, beavers affecting wetlands, and probably a dozen other threads we haven't even identified yet. If a story about nature sounds too clean, too tidy, too perfectly cause and effect, that's usually the moment to get curious instead of just impressed. If this just rewired how you think about food chains, subscribe, because tomorrow we're taking apart another simple story that turns out to have way more threads than anyone advertised. So the next time someone tells you wolves single-handedly reshaped a river, you can nod because it's a genuinely real phenomenon, and also gently mention that the real story has a few more characters in it than the highlight reel usually admits. Nature doesn't do simple. It just sometimes lets us tell it that way.